Hello all and welcome to my YouTube channel. So today in this particular video, I am going to be discussing about automated library which is called FLAML prepared by Microsoft, which stands for Fast and Lightweight Auto Machine Learning Library. So this library is very helpful and it has been helping me to build the projects around the different kind of domains. So I have been using this library particularly to get an understanding of the data and preparing the data and getting the best model out of it. So it's just very quick and very fast and reliable library. It can be used for hyperparameter tuning as well. It also supports many kind of hyperparameter tuning algorithms, and we can also customize these things inside it. It's not properly an automated library, but yeah, in a fashion we can say it is automated machine learning library. But we can also configure our things inside this particular library, and we can provide our custom models which are not included into this particular library. We can add custom metrics, we can add custom tuning parameters. So all those custom things can also be done over here with automated facilities. So what this particular library does is it actually takes up the data, prepare data, and it just train the model, varieties of model, and give you the comparison report regarding the best models which is available inside this particular library. And it configures each and every model and prepare a matrix and give you the best model out of it. And and you can also use this for hyperparameter tuning. So all the hyperparameter tuning is being done parallelly when it's getting trained. So this facility or this machine learning model or this particular library helps me to get and proper understanding of the models which I can use it for the particular data set. And it's very fast and quick. So within a second or within 5 to 6 minutes, I get to know like which is the best model, and I can focus on that particular model and get on it and improve it. So that's how this particular library helping me in my particular projects, and hopefully it will help you in your projects as well. So let's take a look into this, how this works. It's very simple. In a 3 or 4 step, you can just implement it and understand how the library is. So so to begin with the installation, we have to just install this particular FLAML, and we have to also install the notebook version of this. And then we have to just import this AutoML class from this particular FLAML, and then we have to just pass the train data to it, and we have to specify the task, like which kind of task you want to be doing it. So this library also support uh, uh, time series, NLP kind of task like summarization and sequence classification and regression. So such kind of things are also available over here. So right now we are going to see just in classification task, and we'll see the whole process how the things are being done. Later on you can also go into this particular documentation, and you can see how the things are being done over here, and what are the cases that can be used over here. So if you see into this example section of this FLM AML docs, you can see there are varieties of tasks being given over here. So you can see classification task, NLP task, rank task. So ranking also being given over here, regression, time series, and you can also tune your transformer models from here. You can also tune your PyTorch models over here. That is new network models. So this library is kind of getting you a model, as well as you can also use this as a tuning. So it's just not like you cannot use it as a standalone library. It's like it's like in a different library. You can use it for different multiple purpose. So this library help us in many ways. So this is what this FLM library gives us power to go through the particular functions and explore the things. So let's get back to the particular GitHub repository of this particular FLML. So here we were defining the things about AutoML, and that's what we have to give here, data, and specify the classification task, and then we have to fit an AutoML model. That's it. That's what we have to do. And you can also give a estimator list, like if you want to purposefully you want to use a single model, so you can also give it over here, like you can pass an argument, estimate underscore list, and pass a parameter over here, lgbm, and you can just take on this particular AutoML library to focus on to this particular lgbm classifier model, and it will train only on this particular model, and it will tune it, hyper tune it, and it will give you the result. That's the beauty of this uh, FLML. So the thing is, while tuning it has already been defined the speech, the search space, and everything. So the tuning that is being done internally, their search space has been given, that has been defined by the Microsoft, and that particular search space is being used to define or tune the hyperparameters while training these models. So that's the flexibility you can get. You can also customize that search space if you want, but I would prefer this custom search space, and even the automated search space to tune my model. So I do it in the both ways and get to the best model in a very few amount of time. So that's what the classification, and that's what about the FLML. It's just a three line of a code, and we can use it. So let's go to the collab tutorial, and let's understand how this can be done in a better way. So first thing, we have to install this particular FLAML library. That is, so here we are going to use the notebook version of it. So we are just going to install it, and once that is installed, we have to just load this data set. So I am just using airline data set, which has been already been given inside this FLAML, and I'm just loading it and splitting it to the test and train data set. So let's just run this, and once that is done, we have to just import AutoML from FLAML, and we will just initiate this particular class and store it into the particular variable, which is AutoML. So once this is done, we have to specify some settings. These settings are nothing but the parameters which we are going to pass inside this particular fit function. So these settings are nothing but the parameters. So we are just going to pass this some parameters inside it, like time budget. So how much time you want your model, or you want your AutoML model to run. So we are giving 240 seconds, and what metrics you're going to be using. It can be R2, RMSE, MAE, like anything you can give over here. Right now we are giving accuracy, so you can see, and we are specifying this as a classification task. You can also give any regression task, or you can write any rank task. So such kind of things you can do, and you can also log files, whatever the experiment, whatever the things are being learned over here while training the model, it's going to be getting logged over here in this particular file. So we have to specify this file name and the random seed to just execute for this particular training data. So this settings will initialize it. So these are parameter settings, and once these settings are being initialized, uh, we're going to use this AutoML dot fit function, and we're going to pass this x train and y train, and then these settings are going to be passed into this particular AutoML dot fit. And once we initiate this particular fit, once we initiate this particular AutoML training, it will take few amount of time, like 240 seconds to get it trained, and we're going to see the training to start with better accuracy. So let's see how does it performs. So you can see it is being using task as classification task. It has used data split method stratified. It has also used evaluation method holdout. So these all settings are being given inside this fit function. You can explore this fit function inside this, and you can also change this particular methods available over here. And if you go to this particular GitHub repo of this FLML, and you can find these settings over here about this particular data split methods, invalidation method, like what are things they have given. If you go into this FLML, and if you go into this automl.py, if you scroll down to line 400, you can get an better understanding like what are these things and how you can change up this particular parameters. So if you see, uh, we have this data split method. uh, if we find it out by using data split, okay, it's gonna take time. Let me do it manually. Yeah, so you can see, here you can see evaluation method. So here we can specify auto, CV, and holdout. You can also specify these kind of parameters. So these all things are being given over here. You can just play with this and pass these things as a parameter into this particular fit function and get the things done. And similarly you can pass the accuracy. So we are going to minimize this one minus accuracy, so we are doing so. And we can also pass this list of AutoML learners, and these are the things which we are going to be doing it. So that's how we have these things, and we can prepare this customly over here. So you can see there are many LGBMs models are being trained, and XGBoost models are getting trained. Uh, Even XGB limit depth is getting trained, and cat boost also getting trained. So likewise we can this model is this FLML is training all such kind of models with hyperparameter tuning. And once this is done, it's going to produce a model that is best suited for this particular data set, and it will just initiate that model once this training is being completed. So that's how this is being initialized, and let it train for a few seconds, and then we'll get back to the particular evaluation of this model. Okay, so you can see the model training has been completed, and uh, it has taken all such kind of models which has been specified inside this estimator. So you can see it has trained on all these kind of models, and finally we can we can see and print the best estimator, that is best model with best parameters, and what is the loss it has taken and how much time it has taken to train. So there, those all information can be printed out here in this particular cell. So we are just using automl.best estimator to automl.best config to print out the best parameters and the best machine learning model. So let us run this particular cell and understand which model it has printed. That is it has got best model. So we can see it has taken LGBM as the best model, and we can see it's saying best accuracy validation data is accuracy is 66%. So which is quite assumable because we haven't trained it for a long time. We are just given 240 seconds to train it, and it's just a matter of time. And if we increase the time, and if we give it more time to train, it will it will generally will give more best results, right? So, and these are the best hyperparameters it has chosen to get onto this particular accuracy. So by default, if you see what kind of hyperparameter model it must be using, that must be a question. So if you go into this particular FLML library, and if you go into this particular documentations of this FLML library, if you scroll it down, you can see it has been using an hyperparameter model which has been discovered by or researched by Microsoft, which is also known as cost data hyperparameter, which is CFO. and it is also using blend search. So by default, if you don't provide any kind of custom hyperparameters algorithm, it is actually being using CFO. So right now in this particular FLML is having CFO and blend search as an hyperparameter or algorithm to tune the hyperparameters, and it is one of the best, and we have been using this lately. So CFO and blend cells are being used, but by default CFO is being used at the backend when it trains the model uh, for the best results. So that's what it is being doing at the backend. And let's print out the best estimators. So you can see it is using LGBM classifier, and these are the parameters. So once the training is done, we can save it in the form of pickle format. So we can save this model in the form of pickle format, and then we can also load it. So that's how we do it. And once that is done, we can use this AutoML.print to print on the test data set, and we can print on the and print the probabilities as well. So this AutoML.print underscore probability will help us to give the probability of the particular model. So that's how the results are. You can see predicted labels are 101, and the true labels are this, and it has stored this probability inside this. Similarly, you can measure the accuracy scores. So you can measure the accuracy, ROC, and log loss. So we have to just provide this particular function, that is SQL metric log loss, and then we can do all this metric calculations very easily. So you can see the accuracy is 67%, ROC and UC is 72%, log loss is 0.6, which seems to be feasible because we haven't trained for a longer time. But yeah, it's quite low as per this. But if we increase the time of training, we're gonna get this particular accuracy to near to around 80 to 90%, and that's what this particular algorithm is built about. So for this tutorial I have restricted the timings, so 240 seconds is very less. That's the accuracy we are getting at this particular time of training. And now we can just see the logs, whatever the logs it has been used for training. So different models and different logs has been captured inside this. And we can also print the learning curve, that is how the best model has taken and where it has taken the learning to at which level. So how this has been processed while validating the things while logging the accuracies and all. So that's how the model has been learning over the time. And um, and we can compare this particular AutoML library's accuracy and performance with respect to default classes that by using customly using LightGBM and XGBoost. So we are just importing these things, and we'll compare the performance from these trainings as well. So let's just take this default parameters from LightGBM, and we feed the same training data and let it get trained on the default settings, and we'll compare these results with our current results. So once that is trained, we'll just spread this the results on the test data set. Similarly, we're gonna training XGBoost on our train data set, and we'll compare it with the FALML data. So let's do this, and let's fit this, and let's just print once the training has been done. And we have to wait few seconds because XGB takes a lot of time to train. And once that is done, we can go ahead and print out the results for the predictions. And okay, so it has trained the XGB classifier, and now we can take the test data set and predict it using this default settings model, that is XGB model. And now we can compare the FAML model and XGB model and LGB model on the default setting. So let's just run this. So you can see by default settings, XGBoost has produced 64%, and LGBM accuracy is 66%, and FAL MEL model accuracy is 67%. So you can see it has taken just 4 minutes to train FLML with tuning. Uh, and you can see by default settings, these models are performing underperforming with respect to FLML. So that's how you're gonna choose this particular FLML AutoML library, and that's how you can compare with other models, and you can understand which kind of model you can focus on with what hyperparameters. So now you don't have to worry upon the things like what kind of search space I need to provide, and or how much search space, what should be the length and all. So that things you avoided, and you can mainly focus on the data, and training process can be automated and can be understood very fast, and you can do that model training in a very good way, plus more accurately. So that's the help we can get it from this FLML library, and I have been using this particular things lately. So I'm quite impressed with this particular FLML library. And now so we can also determine the custom learner. That is nothing but let's suppose you want to use different models which are not the part of FLML, like XGBoost is a part of it, LGBM is a part of it. But let's suppose there are many algorithms which are not part of this particular library. So you can define this custom learner, and you can just train it by using this custom model that is not been a part of this particular library. So you can, let's suppose so for example, I've given here regularized greedy forest, which is not a part of this particular FLMA library. So what we can do is we have to just initialize these things, and we have to prepare a class, and we have to specify the task, the type of task. Generally, like if it is regression task or classification task, we have to use this estimator and this estimator. And then once that estimation estimator is being specialized or initialized, we have to pass the search space. So you can see internally we have to provide this search space when we are building this custom class. So likewise, it has been done in the SGB boost and other things inside the FLML. So we have to specify this search space, and we have to give the optimal size and cost functions. And then once this is done, we have to initiate this particular cell, and that is done. That's it. So that's how we initiate this particular custom models which are not a part of this. And this all things, all steps are being given inside this particular documentation. You can go and follow this particular documentations. You can easily understand how to prepare this particular custom classes. You can see step by step they have given to prepare a custom estimator if you don't have into this particular library. So we can prepare this step by step. It is being given, and you can define the search space. Everything is given here, and you just have to read it and apply and add it to this particular library. So that's the customization you can have, and that's the agility you can get over here. So that's how this FLML being used as a custom learner. And what how we can use it is we have to initiate this AutoML, and this AutoML we have to add learner, and we have to add this new learner that we have created above here, and we'll define the learner class that we have created over here. So that's how we'll add a new learner to this particular AutoML, and we'll just initiate this particular cell. So once that is done, we have to specify the settings. That setting, the same settings, whatever we have specified at the top, the same settings are coming into play here. And this time we are giving this matrix accuracy estimator list is like RGBF, LGBM, RF, and XGBoost. So we have reduced the estimator list, but this time we have included this RGF, that is our class that we have created right now, and we are specifying the classification and the log files and metrics to be logged. So that's how the settings being initialized. And once that is done, we have to fit the function, and we have to use the fit function, and we have to apply the train data set, and we have to apply this particular settings. So once that is done, we can start training, and it will start training the model, and it will use the RGF model, which were not a part of this particular FLAML, but now we have defined it customly, and now it is being trained with that particular model as well. So you can see the training has been completed, and we can see the best model it is putting out is still an LGBM classifier, but it has trained RGF model as well, you can see. So that's how you can define the custom model as well, which are not a part of it. You can also define a custom matrix, which is not a part of this. So you can create the custom matrix and do the similar things. And once the custom matrix is being configured, you can initiate this AutoML the similar way, the same step. And then in the setting, inside setting, in the metric part, we have to specify this custom metric. But this time, until this time, we were just specifying the accuracy. But now, since we are using custom metrics, that our own metrics, so we have to pass this custom metric function that we define it above and here, and the similar way the settings has to be initialized, and then we have to train the data set. So this whole process is very similar. Only the things are like the custom things has to come into play, and we have to keep on specifying the custom things over here in the parameters. That's how it is, and that's how the simple FLML library is. And this library will be helpful in terms of experimenting different kind of model with different hyperparameters, and it can be used with better it can be used for better results. So I do use it, and I get to the best models very quickly with with the best hyperparameters. So that's how you can do it. And let's see how we can prepare one more video on this uh, to take a look at how we can fine tune a custom model by using this FLML. So that's all about this particular video. Hope you enjoyed it. Please do subscribe my channel. Thank you.